So on the second part of our lesson, we are going to look at boiling and heat of vaporization. I think what I'll just say a few things quickly here. With the way, for example, let's talk about evaporation first of all. All right, so let's talk about this word, evaporate. So imagine you have a dish of water, right? Do this experiment, all right? Get a very small amount of water, just small, so that you can know the difference as you sleep tonight. Okay, so this is experiment number 3, lab 3, if you are getting me. So lab 3, what you do is just sprinkle, if you want, just sprinkle in a dish. Sprinkle water in a dish. Just sprinkle it and leave the dish on its own the whole night. You wake up, you find the water is not there in the dish. Who stole the water? Okay, but okay, try and make that experiment to see if you wake up and find water there. Just sprinkling. Don't like put even half full. No, just get water in your hands and sprinkle it in the dish. Leave the dish overnight. You will find the dish, the water in whatever state you want. You find, you report. All right. So now, but one thing I just wanted to mention is that with evaporation can happen at any temperature. All right. So you leave a water like this dish which you see here. All right, this dish or any liquid. All right. What will happen is that some of these molecules of the liquid which are in this liquid, all right, you find that some of these molecules have a higher energy than the others. Because when you talk about heat, for example, if we talk about a temperature that, okay, the temperature is maybe 15 degrees in this liquid, and then probably we can convert that information into energy. Like, for example, we say, okay, this basin has about maybe 200 joules of energy, average energy, all right? But some molecules here have more energy than other molecules. So they'll probably even have higher kinetic energy. So they'll be moving at higher speed, such that even if there's a barrier called surface tension, or there's a bond between, similar molecules, that bond that exists between similar molecules, water molecules, how they attract each other. So if some of the atoms or some of the molecules have more energy, they can easily escape this liquid. They can escape. And that escaping is what we call evaporating. When some molecules gain more energy and break the bonds between similar molecules, what will happen is evaporation will take place. It can happen at any temperature, even at freezing point, 0 degrees, 20 degrees, as long as some of the molecules have more energy. So, and the heat that is required, for that situation which you're talking about, all right, for a molecule to escape and evaporate, the heat that it needs, the energy that it needs to have, is called heat of evaporation. Heat of evaporation. Sometimes they say just heat of evaporation. That energy, heat of evaporation, is the energy that is required, is the energy of a liquid required to tear the unit mass of molecules. In simple language, heat of evaporation is just that energy that molecule having a unit mass, the energy it requires to escape and evaporate. All right. So here the formula is a bit different. Remember, there in the first instance we had change of energy, Q, all right, was equal to M see change in temperature. That is the one that we are from looking at. But for heat of evaporation, right, or the energy, this energy required to evaporate is just Q, all right, is equals to mass times HV. This will always be given for any substance. For water, for whatnot, it will be given. All right, this. So here there's no change in temperature. We don't look at change in temperature here when something is evaporating. We just look at it like that. So there's no change in temperature. There's just a mass times HV. That is the heat required to evaporate. Are we together there?
Yes.
Yes.
Okay. So usually we expect much, as we'll see in the next section, we'll see that much evaporation is expected at boiling point. When something is boiling, we expect it to be, you can even see the water vapor rising, all right? And when, as you will see at a later stage, we'll see why we don't put change in temperature here. We don't put this change in temperature, right? Here we are putting change in temperature when we are looking at a specific heat capacity. Because specific heat capacity, we defined it as the energy required to change the temperature. But for this HV, heat of evaporation, it's just the energy that is required for a unit mass to evaporate. All right? Okay. So now, what happens when evaporation takes place? So when evaporation takes place is that when some of the energy, when some molecules, for example, those which are at the surface, have more energy and then they escape the liquid, these remaining these remaining molecules, since some those escaping molecules have gone away with even energy, the energy which was they have gone away, the remaining molecules will remain with less energy. All right, now when they remain with less energy, you will discover that even the temperature will reduce. All right, temperature will reduce. So if you had this whole basin was at 20 degrees, as soon as some molecules of water starts evaporating, you discover that when you measure it, it will be even at 29, something like that. Because these guys who are evaporating have taken away heat, all right? And so let me just ask this question quickly. Where do you see this happening in life? Where when when some molecules evaporate, temperature is reduced. Where do you see this happening in life?
It happens to us like when you're sweating. When it's hot, you sweat. Then your skin goes down.
Yeah, that is, this science, even before you came to NS, your body knew it. It knew that if I remove sweat, if it's hot, what Tekla has to do is to remove water and put it on the surface of her body. So as that water will be evaporating, that water will carry away heat, energy. It will carry away energy. So when it goes, it will leave the body cold, cool. All right. So you guys, when you are feeling hot and sweat is coming on your body, don't wipe it. When you get a towel and wipe out that sweat, you are disturbing the system. The system is that water has to go away on its own. So you find that it's hot, you keep sweating. You keep sweating in an exam, Soka. You find you are there sweating. Don't get a handkerchief and wipe it. It's helping you. Just continue writing. Don't mind the sweat. Is that okay?
Sounds okay, but
Hey, yes.
That's the formula, right? So you just keep writing. Don't mind the body. The body is one. It wants to help itself. It wants to cool down. Just keep writing. So the body knows science. It knows that if I remove water and put it on the surface, the air, the environment will take away this heat by evaporating. So evaporation will take place and the body will remain cold. So that's very important. It knows the heat of evaporation. It even, anyway, so let's just continue and look at this table. So this table is telling us about, different substances. We have water, we have Hg, this one should be mercury, we have oxygen, we have nitrogen, we have, some other substance which I don't know. So these substances have different heat of evaporations at different temperatures. So if water is at 20 degrees, its heat of evaporation is different. If it's at if it's at 100 degrees, its heat of evaporation will be different, just like that. All right. So heat of evaporation is also sensitive to temperature, but it's pretty much constant. From 0 degrees, it doesn't change much, and it changes much until it reaches 100 degrees. Otherwise, the idea that we want just to know is that there is heat of evaporation, the energy that is required to change the temperature. So when we talk about temperature and evaporation, just continuing on with our discussion, is that what happens is for example, if you have a tub like this, all right, a tub like this, you put a covering on top, and then put water there. All right. So what will happen is water will start more like evaporating, but again, as it starts to evaporate, it will also start condensing. All right. Because these evaporating molecules, when they go up, whatever goes up must come down. So you find that they have lost energy. They will start coming down and condense. All right. Some will go up, some will go down. So what happens is that as this continues to happen, all right, some molecules are going up, are evaporating, some are condensing. At a certain point called saturation, saturation, all right, it will so happen that the number of molecules that are evaporating will equal to the number of molecules that are condensing. All right, condensing, we see this condensation happening even in normal life. We see rain. Where is the rain coming from? Are there some angels holding drums and pouring on the earth? No, these are just natural processes which God has put in place to say water can evaporate, but again, water can condense. All right. So, but at a certain point, there's a saturation that is reached. And that saturation, let's see if we can find it. So there will be that saturation that will be reached. And the pressure, all right, the pressure which is above this liquid, due to as some molecules are evaporating, they'll cause pressure, all right, pressure on the liquid which is down. And this pressure, we call it vapor pressure. All right, we call it vapor pressure. All right. In real life, what we usually happen is we have an open spaced, scenario where a liquid is, evaporating like that, but the air around it, all right, the air around it is exerting pressure, and this pressure is usually due to atmospheric pressure. All right, the air around it is exerting pressure, and what happens is that what happens is that that pressure reduces the likelihood of evaporation. Anyway, those are just some of the things that you have to know. Sometimes may ask you in a multiple choice question, but those you can read, you can pretty much read on your own. And so here there's a scenario where you put, this one is a stove. I don't know if you have seen this. There's a pot. I don't know if you have seen this. There's a pot, and then you are put on a stove. So you find gas bubbles forming in the pot. As vapor will be trying to rise up, all right? As vapor will be trying to rise up, they will find air pressure, all right? What we are calling air pressure. And then due to this air pressure, they inhibit evaporation, all right? If you remove this air pressure, water can boil even at 70 degrees, all right? Water can boil even at 70 degrees if you remove air pressure, all right? So when if I ask you that, at what point does water evaporate? Normal evaporation for water. So you don't just say, okay, water evaporates at 100 degrees. No, it's not enough to say water evaporates at 100 degrees. There's also an aspect of pressure that you have to take into consideration. And this pressure at which water evaporates is, when we talk about 100 degrees, we should also talk about 1 atmosphere. All right. Under atmospheric pressure, we expect water temperature of evaporation to be 100 degrees. If you increase this temperature, also you must increase the temperature. If you reduce the pressure, the temperature at which it will boil will reduce. Even at 10 degrees, water can boil. 10, so water in your hands, just like this, at 10 degrees, you see it boiling because you have reduced the pressure. So quickly, we are saying boiling is boiling temperature is the temperature at which the vapor pressure in the bubbles equals the external pressure on the liquid. And so when these bubbles which are forming inside here, the pressure inside those bubbles, when it equals the pressure of the atmosphere, at that time, any increase in temperature will cause the gas to start escaping. All right. And those gas bubbles that form in water, all right, those are what we call boiling. When you see those gases forming, it's boiling. So that's that. So it's pretty important information that you need to know. And I'll leave you because I'll send you these things. So you must read all these things to appreciate this. But the idea is that whenever we talk about boiling, we also need to talk about it. Whenever we talk about boiling, we just don't need to talk about the temperature. We also need to talk about the pressure. All right. So take note of that. All right. So I think for today, we might just end here. I have no homework because mostly this is just theory that you guys need to digest and probably read and get to understand. But one thing I can encourage you is that enjoy the science. All right. Have that mind of saying, wow, I want to know the science behind boiling. How is it that this liquid is boiling? Is there some magic happening? If you can appreciate the science, then school, you will find it interesting. But if you can, have a closed mind of thinking physics is difficult, it will be hard. And also one thing I would like to mention is that, since we'll be opening, God willing, on Monday, it is going to become a bit hard to continue the lessons. I don't know if that Sunday program, maybe it can work, where we used to just meet with everyone on Sunday. I don't know. I would need to check my schedule because also I'm also being tied up because I'm not going to move into school. I'll be coming from home, so it's also an added challenge. So I wanted, if we can finish this topic well and good, then we'll probably after that we'll be just dealing with question papers, because I'm sure this is the last topic that you guys are going to learn, and it's the last topic that you are going to be examined on. So if this topic is done, it will be very good, and we'll try and make arrangements for continuing when we're in campus, but it is going to be a bit tricky. Are we together? Are you guys still there?
Yes, sir.
Yes.
Okay. So I guess tonight I'm going to send this, including some other information which we have not looked at, which will hopefully cover the next time we have a class. Then we'll see where we'll go and where we'll reach. So have a wonderful afternoon.
Thank you, Sam.
Okay.
Same to you.
Awesome.